This module, the online training for the ODOT Analysis and Traffic Simulation, or OATS, manual provides information on setting the limits of the traffic analysis. In this module, you will learn how to set spatial and temporal boundaries for performing traffic analysis. The analysis boundary depends on the operational influence area, which includes the portion of roadway network being improved, plus the surrounding traffic network that has an impact on the operations in the project area. This area could range from one intersection adjacent to the improvement limits to over 2 miles outside the project. Proper identification of the influence area increases the level of accuracy of the traffic analysis in replicating real-world traffic characteristics. In the example here, only the ramp terminal intersections are being improved. However, the operational influence area includes the signalized intersections adjacent to the improvement area. The analyst should initially conduct a field inspection to determine the extent of any existing congestion and identify any hidden bottlenecks. The field inspection could involve reviewing video or drone footage throughout the study area. Hidden bottlenecks are formed when the existing demand at a segment or point is constrained by upstream bottlenecks. In such conditions, corrections of the upstream bottleneck by the improvement may shift the bottleneck to a downstream capacity-constrained location. For example, gridlock was a common occurrence on Interstate 670 in Columbus near the airport during the evening commute. Upon review of this segment, it was determined that the traffic metered by the gridlock on Interstate 670 was allowing for acceptable operations at the interchange of Interstate 670 with Interstate 270. If capacity improvements were made to Interstate 670 to mitigate the gridlock, the Interstate 670 and Interstate 270 interchange would be a new source of gridlock. Therefore, when analyzing improvements to Interstate 670, the limits of the analysis had to include the Interstate 670, Interstate 270 interchange. The minimum study boundary for analysis performed in urban areas are stated in the State Highway Access Management Manual, also known as the SHAM, for traffic impact studies, and the Traffic Academy training material for interchange studies, interchange justification studies, interchange modification studies, and interchange operations studies. Analysis boundaries for corridor studies that do not include an interchange will include at least the first adjacent signalized intersection on either side of the study intersections. There are several instances when the spatial boundary expands past the minimum limits. Bottlenecks that affect traffic flows into or out of the study area. To the extent possible, the analysis boundary should be free of congestion. Bottlenecks outside the minimum analysis limits should be included to determine the impacts within the study area when the bottleneck is removed. Queues at study intersections that extend past the minimum limits, similar to bottlenecks, the analysis area should encompass the queuing to determine the impacts when the queuing is alleviated. Major system service interchanges just outside the minimum boundary limits. These large interchanges could affect the lane changing behavior in the study area and should be included in the model limits. Existing undersaturated condition that could become oversaturated by the design year. Expansion of the analysis boundary should be considered to ensure the model limits will be undersaturated in the design year. Adjacent intersections, because of being part of a coordinated system, may affect the formation of vehicle platoons along the arterial. If the project is within an arterial with signal coordinated system, the analysis boundary should be extended to the extent possible to include the effect of coordinated signals. Examples of some of these situations are included in the next slides. Assuming a corridor improvement study is being conducted for 4 signalized intersections along US 33, typically the required analysis area would be covered by just including these 4 intersections. However, because the major interchange of Interstate 270 and US 33 is just west of the improvement area, it is recommended that the interchange be included in the study area. Lane utilizations, especially to and from the westernmost study intersection, are likely affected by the interchange configuration. Therefore, these effects should be modeled in the analysis. Furthermore, this interchange should be included in the analysis to ensure that improvements at the signalized intersection do not back up and adversely affect the interchange and interstate. A corridor in Ohio has 7 coordinated signals. 4 of the intersections are being evaluated for capacity and safety improvement. Per the guidelines, on the 4 intersections plus the 2 adjacent signalized intersections would be required to be included in the analysis. However, because the intersections are part of a coordinated signal system, the 7th signal should also be included in the analysis to accurately model the formation vehicle platoons along the corridor. For an interchange along Interstate 270, the minimum analysis boundary would include the interchange to the east and to the west of the study interchange. However, the analysis boundary should be reviewed because there is known to be gridlock and backups occurring along Interstate 270 in this area. When observing the queues, the queuing extends for more than 5 miles beyond the minimum analysis boundary and includes a number of other interchanges. In this case, it is impractical to extend the analysis limits to an area free from congestion. Therefore, micro-simulation with transmodeler should be used to complete the analysis. It is also critical that the analysis limits be consistent across all alternatives, including the no-build alternatives, so that the system metrics such as vehicle hours travel, vehicle hours delay, and travel time can be compared when using transmodeler. The temporal boundary limit is the duration of the traffic analysis period. The duration of the model should allow for the buildup of congestion and the dissipation of congestion. This means that there should not be queues that extend outside of the network when the analysis period is over. For locations where traffic flow is oversaturated, a single 15-minute traffic analysis period is typically not sufficient to quantify the total delay and queue length on the corridor. A multiple period analysis would be used to capture the effect of demand that is not served by the facility from one 15-minute interval to the next. The multi-period analysis should account for the residual queues, also known as unmet demand, from one period by using them as the initial queue in the subsequent period. It is important to note that in this type of analysis, the first and last periods of the multiple period analysis should be undersaturated. While ODOT recognizes the potential benefits of multi-period analysis, ODOT's requirement is that all traffic analysis be conducted as a single analysis period. A single analysis period is considered to be 1 hour. The use of multi-period analysis may be required in a future update to this manual. In summary, the boundary limits for various project types are identified in the SHAM and Interchange Study Traffic Academy materials. There are several cases when the minimum analysis boundaries are not adequate. Work with the ODOT district staff and Office of Roadway Engineering to determine the acceptable analysis limits. Unless otherwise determined, temporal boundaries for all ODOT analysis should be a single period, 1 hour in duration.